Previously, we talked about the combined effect of shear and torsion acting onto a reinforced concrete member. It was mentioned that designing a member subjected to shear and torsions together, we need to be careful. We cannot design the member to resist torsion and to resist shear load separately, as the combine of shear and torsions can lead to less resistance when either of them is acting alone. This is shown in the figure here, where you can use up 100% torsional load capacity in the absence of the shear load. Similarly, you can use up 100% shear resistance when there is no torsional load. However, under the combined effect, the shear resistance and the torsional resistance will reduce. And then in our previous videos, we introduced to you two formulas known as the interactive formulas. These interactive formulas help you to identify whether a section will pass under the combined effect of the shear and torsion by looking into the percentage of this capacity being used due to the shear and torsion. The summations here cannot be more than 1.0. Exceeding 1.0 means that the section would fail. It depends on the quantums of usage on the torsions or on the shear. If you use up most of the capacity from the torsion aspect, that means it leaves to you very little room for the shear resistance. Similarly, if you use up most of the capacity in the shear, that leaves you very limited rooms in the torsion. We also mentioned about the conservative measures adopted by Eurocode 2. This interactive formulas here itself is already a conservative measures. Also, if you observe the capacities, both the load capacity in the torsions and the shear comprises the strength reduction factor, which if you look into the fundamental derivations, you have no such factor. This factor is added by Eurocode 2 as a factor of safety for a conservative design. Now, you might be curious, although it is shown the parabolic curve here, indicating the relationship between the capacity used up in the torsions versus the capacity used up in the shear. But if you observe carefully the interactive formulas, the relationship obviously is not parabolic. Instead, it is a linear relationship. The summations of the capacity used up in the torsions versus the capacity used up in the shear are not greater than 1.0. That means the applicable regions as restricted by this interactive formula is actually this area. As far as the equations is concerned. However, in the reality, you have an additional safe region here, which is beyond the boundary of this interactive formula. In another word, this interactive formula has already trimmed this safety regions here, assuming it is unsafe. Whichever not fulfill the formula, the section will be considered failed. That's why I say this formula is a safety measures. Also, we mentioned that we cannot design the torsional resistance and the shear resistance separately, assuming that they will perform as per what it was predicted under the combined state of the torsions and the shear. The reason here is if you design the torsional resistance separately and the shear resistance separately, then this will lead to you a unsafe region here. You might overestimate the capacity of the member and it falls within the unsafe region here. The member will fail. To make it simple, The message which I would like to deliver from this diagram here is, first, you cannot design the torsional resistance and the shear resistance separately, as you're going to overestimate the capacity, leading to premature failure when the member is subjected to torsions and the shear loads together. The parabolic line represents the actual behavior. However, for simplicity, we use the interactive formulas to do the design. This interactive formulas itself is a conservative measures, which trim away the safe regions outside of the linear relationship between the formulas. Whatever sections falling within these regions, although it is safe, but it is not recognized by the formula. Therefore, as far as the design is concerned, we will fully abide to the interactive formula. That means our design will always fall within this region. Anything beyond these regions shall be considered failed.